Welcome you all for the mobile application development lecture series. This is Ashwin taking up the module 2 lecture 1. So today's is a very interesting topic which we are going to discuss and which we are going to learn today. What we are doing today is exclusively getting started with one of the most important mobile application development platform, that is Android. So today's topic is all about understanding the Android architecture. So to get started before the Android architecture, let's recall what did we learn in the module 1. In the module 1, exclusively what did we talk about was with respect to the user design, user usability, user acceptance, the testing, and we spoke about different ways of designing a UI. Let's first recall about the module 1 and then we shall take it up the Android architecture, or we can start introducing to the Android. So today's lecture is all about what is Android, why Android, Android software stack and Android development environment. Before getting started with the application development, we should understand how the architecture, the complete view of the architecture, so which you can see which is ready right now for the explanation. And before getting into the today's lecture, let's recall the module 1, what all things we learned it. In the module 1, we spoke about mobile applications. What are the different types of mobile applications available? Why do we need mobile? What are the different kinds of users who are going to use it? The preliminary consideration, why we have to consider the mobile application in front of the web application. Then we looked into the various difficulties while developing a mobile application. We looked into all these aspects and what all the myths we have in our mind. And all these things we discussed with respect to a decade before when the actual mobile started. So this was the first thing which we discussed. Later we discussed about the very important UI principles. How do we design a UI? What all the technical terms which we need to see based on the research. They have found out different ways, how a human mind works, what exactly it captures. How do you do a continuity if there is a missing? How do you do a figure and ground, background color, what should be the front end? So all these things we discussed in the UI. Then we spoke about different social aspect of the user. Then we looked into the usability. So which means which are different kinds of users who are going to use it in different label and all those things. Then we looked into the accessibility, where what are the different gestures we are going to use, what all ways an information can be conveyed. Then we looked into the information exclusively with respect to the design part of it. What do you mean by information? Information is a purified form of a raw data or the processed data, we call it as information, where how do we exactly convey our information to the user? This is what we try to do that. Then we looked into the design patterns, various design patterns which are available for a better information display. Then content and control. Then we looked into the intervening screens, where we have different kinds of screens, which means when there is an idle time or some process is running behind, what exactly we have to look into it. How exactly in the screen can be brought so that you can convey user something is happening. Then we looked into the advertising part, in which area it is good to advertise without disturbing the user interference. Then looking into the content structure and the usage. These are all with respect exclusively about the information design with respect to the UI. Then we looked into the various mobile platforms, say iOS, Android, Windows, BlackBerry. And we looked into the advantages and disadvantages of each of the platform. And we looked into the individual small, how exactly the architecture looks like. Then we looked into the various market share of individual platforms. All these things we looked into in the first module, where exactly we got into the introduction to the mobile application development, various aspects of mobile application development, the business perspective why we have to consider. This was our very important focus towards our mobile in the module 1. And right now, in today's class, we are going to get started with Android, a very important platform which we have been waiting from past quite a few days. When do we start developing an application? How exactly, is it easy, is it difficult, everything. So we are getting started. In the next class, we'll be actually running a small application, whereas in today's class, we introduce you to the Android, where how exactly the architecture looks like, so that you can, when you're building, what is happening, you can imagine what's happening in that. So today's class is exclusively to the introduction of Android architecture or Android application development. So welcome you all. Let's get started then. What is Android? In fact, we have been discussing about Android from quite a few times. Android is a mobile operating system, which is an interface between a mobile hardware and the user. So we have even looked into the architecture of an Android or any OS which we have. There are quite a few. If you have looking into it, we have an hardware. On top of it, we have an OS, and here we have a user. Irrespective of anything, if you want to interact with the exact hardware, then we need a OS. Irrespective of the device, it could be a refrigerator, it could be a washing machine, it could be your AC, it could be your projector, it could be a camera, it could be a laptop. Every device has an OS running onto it, because this OS is the one which is going to talk through its drivers. With the drivers, we are going to control. It is very exactly similar to our vehicle. Vehicle is run by a driver. So driver is at present a user. So like human beings, we are going to drive it. Likewise, these hardwares are controlled by this OS, which are driven. What action has to be happen, the mechanical part. So that is what is the thing. And this is we have discussed what exactly operating system, but exclusively what is an Android? It is also an operating system, a lightweight operating system which can run on our mobile. So we exclusively on a smartphone, which we can say. Next, going on with why we need Android. That's a very important question we have to. Why do we need an Android? There are many reasons why we need an Android. We have discussed in terms of the business perspective. Exclusively, it is because of the business perspective we need Android. If you look at the past few decades, consider from the last 6 decades, from the beginning of 1960, every decade we have improved over the things. So it could be that from a calculator to the first computers, from the first computer in the third generation, we came up with languages, exclusively high-level languages. Then we moved on to the object-oriented programming languages. Then we looked into the independent languages just like Java, which is platform independent. Then once we are done with that, then we move completely onto the internet in the previous decade of 1990 to 2005. So that's where we looked into we developed application exclusively for the internet, where users, because every decade we had an advantages, we had disadvantages. There is a very linear growth in terms of the development of these computers, where we are heading towards. And where we are standing today is with respect to the mobile applications, which means after the internet, the big change happened was with the smartphone, that is exclusively towards mobile operating systems and mobiles. So one of the important operating system which has been conceived by the users is the Android. The other one was the iOS, but we'll be learning both iOS, Android, Windows, everything we'll be learning it. But today we'll be looking into the Android. So that is the reason why we need Android. It has been accepted by the whole world. 76% of the market uses the Android. So one of the important reason, it's an open source. Do remember that it's an open source. If it is an open source, which means you have many applications written using Android. On an Android platform, there is nothing like you do not have an application for this. You have applications for your gaming, for your business perspective, for individual entertainment, social media. There is no field so much applications have been developed other than for Android. Even in the last decade, we couldn't compare how many applications developed. But in Android, every user develops. Almost 50% of this world is working on Android. Applications are getting developed for so many purposes. If you are coming out with a web application, then you'll be coming out with 3 more applications for mobile devices. One is Android, iOS and Windows. So this is how it is. You develop any kind of application, people will ask, do you have an Android? One of the simple example if I have to give you was the college management system, which in our college we were using the GEMS. GEMS was getting, earlier when they introduced, it was in our college we were using web application. And what was the biggest problem was, we as a faculties or students we have lack of time in this fast moving world. So we need a faster access. We cannot switch on a machine, boot your system, then open a browser, connect to the internet and then open your application, log in and do that. All these things happened. So these 10 steps which we see when opening an application has been done with only 2 steps. Open an application, log in. That's it on your mobile. So this easy it is with the mobiles. So that is the reason it remembers your previous security passwords. It directly logs in. So because it's considered it's a personal item, personal device. So that's the reason we accept Android. The next, if we have accepted the Android because of its reachability to the market and because you have thousands of applications, then what are its features if you have to see? The features which we can observe here is, what are the features if you can have it? So one of the important reason why Android becomes famous was it's an open source. So people during the 2005, there were hardly any mobile operating system which was opened as an open source. Everything was licensed. Consider the iOS, it's a license. Till date, it's a licensed one. Consider your Symbian, consider your Windows. Every operating system was licensed, other than the Linux. So what they did was, one of the important steps they took was, they took out the Linux kernel out of it. They removed all the features, unwanted features. They made it very light, and then they kept your Android libraries on top of it, and they made it run onto your device. This is how they did it actually. So when they did it, they wanted to have a software development kit. What do you mean by software development kit? Any application, if you are developing it, you need various libraries or various tools to work with it. Example, you need an editor to type in your code, you need a compiler to compile your code, you need a debugger, you need a tester. All these libraries, when you're developing an application, you need a built-in functions already written. So where do you get all these different tools? These tools are provided with software development kit. That's the reason we call it as software. It is very similar to your JDK, which consists of loads of libraries. Exclusively, actually it consists only the libraries. It has a compiler, don't forget that. It has a compiler, it has a debugger, it has all the built-in functions other than the text editor in fact. It has what all the tools you require, what are all the functionalities, what are all your softwares, the programs which are required to develop a mobile application. Everything is available in Android SDK. In fact, you don't require anything else if you have the Android SDK. Initial years, 2005 to 2010, the Android was developed only using SDK. it was developed using SDK only. There was no IDE, there was no such kind of tools to do that. So all they did was, some libraries were there was one compiler, they coded it, they compiled it, they was. So that's how the SDK was. Now it has got huge library sets, because more developments are happening, more support is coming in, you require more features, automatically the SDK is increased. So this is one of the important feature of Android. Another one, the Dalvik virtual machine. Nowadays we call it as Android Runtime, which is a very important thing, which I'll very clearly take an example and tell you how exactly it works. Then we have many videos, audio related APIs, the codecs. We have Bluetooth, 3G, 4G, 5G support libraries. We have Wi-Fi, we have camera, we have everything, whatever your user requires, everything is supported by Android. You have list of features supported by Android. Over the period of a decade, many features have been added. Next, the very important aspect, which you don't find it everywhere, is it has a SQLite built-in, which means it has a database of SQL which is very light in nature. It comes along with the OS, which we hardly find it in the different desktop OSs like Windows or Linux. So they have light of, we don't exactly call it as a database, but this is exclusively a SQL database which is part of your Android OS, and your applications can easily write and read from that SQL RDBMS, which is a database where you can execute your insert, delete, create queries on top of it. So this is how, these are the very basic features which I have given to you. The next important feature is the Android stack, which I have to look into it. We are getting started. Now it's becoming interesting. You see something very colorful over there, a system apps, user apps, many things. Let's go in term. The other day we have been discussing about the OS. OS is nothing but the hardware. Hardware is somewhere here, which interacts. And this is completely your Android OS. We represent in terms of a stack, how exactly each on top of hardware, how it is being stacked. That's the reason we call it as Android stack. In simple terms, we call it as a high level design of an Android architecture, and this what you are seeing is a detailed design of an Android architecture. Let's see first the Android stack. If you are looking into the Android stack, in the bottom you have an hardware, which is on top of it we have a kernel. Do remember, we exclusively said Android is built using Linux platform, which is nothing but your Unix, which is running at the bottom and which is lightweight. On top of it we have hardware abstract layer, which means you are going to hide the hardware part. You are going to hide the hardware part, and above applications doesn't have the direct access to the hardware, which is nothing but it is providing you the security of the hardware. Hardware cannot be touched directly by any applications without this layer. So this acts like a security layer for your hardware. The next are few of the libraries which are written using C++, exclusively to make sure that your Android is meant for your mobile applications, which means when you're developing a mobile applications, you require certain basic built-in functionalities, or else your development time is killed. So they have provided you the libraries through which you can, it could be, you consider for basic libraries, you can call it as a sort algorithm, or an swap algorithm, or an string like functionalities. All those things are available part of it. Along with that, the important one, the Android runtime, which I'll be taking it up here. So once this, when I start discussing about this, I'll be exclusively talking about the Android runtime, which is the one which is a core, which is a very important part of your structure, where it is going to convert your DEX file to the platform dependent file, which means your bytecode is converted to the machine code using this Android runtime, which is very similar, which we call it as DVM also, Dalvik virtual machine, very equivalent to Java virtual machine, very equivalent to Java virtual machine. Next, on top of all these things, we have a Java API framework. So what exactly it is API framework, which will be showing it here. It is mainly meant to provide you the libraries to develop your mobile applications directly. Say it could be UI, it could be a broadcast you want to do, or notifications, or you want to have sensors, you want to have access to your database, then all those related things comes under Java API framework. On top of it, we have system applications along with the user applications. System applications like we have a built-in contacts. If you open your mobile, you can observe built-in system applications comes which you cannot remove actually. That's we call it as, which is required which is part of your voice, which means your contacts, your dialer, your messaging. You have a basic OS learning features, applications, which are all applications only, which could be OEM also. As you are running a Samsung related application, then Samsung will give its own application like Samsung Galaxy application, Samsung Store kind of a thing. Those applications which you cannot remove also, which we call it as system applications, which runs on a system and which cannot be uninstalled by the user. Whereas your user applications are nothing but your WhatsApp, Facebook, which you install it from the Play Store, your interest. So those applications you can always uninstall and install. So this is nothing but our basic Android stack, which we call it as the Android high level design. Now I'm going to take you to the very important part, the Android high level detailed architecture. That is, let me introduce to you the detailed architecture of Android, which you can read. The same thing, if you can observe, there is a Linux kernel. This is our Linux kernel. You have a hardware abstract layer. This is our hardware abstract layer which comes in, which is part of your Linux kernel here. Then you have some native libraries and Android runtime, native libraries and Android runtime. You'd be wondering, sir, where is this abstract layer which is not seen, which is part of your Linux kernel, which it doesn't require you to be displayed. So that's the reason we call it as a driver here. It has, the Linux kernel also performs your memory management, resource management, device management, process management. All those things are also available in part of this. Along with that, Linux does all those features. Along with that, it does your HAL, nothing but hardware abstract layer. So these two items are covered within this. These two items are covered within this layer, and this layer is covered, is split, the native libraries and the Android runtime. So the native libraries are nothing but, let's take it up an example. What are all the native libraries? Then we have an application framework, which is nothing but Java API framework. Then we have the applications. This is the application. So you have a 5 level and which has been reduced to 4 level, where in the bottom 2 layers here, this is one layer, this is another layer, this is one layer. So let's learn individually what exactly this architecture looks like. Which we have already discussed, but in detail let's go through. A Linux kernel at the bottom. Here we have a hardware. Here we have a hardware which we can say, and this hardware is spoken through the drivers. Say example, I will give you a very simple example. Today at your home you brought a new printer and or a projector. You are connecting to your laptop. Consider a laptop or a desktop. Printer or a projector has been developed by either HP, Dell, Bank, Epson kind of a people. It so happens that whenever you have come with this, then automatically when it is inserted, the cable is inserted, it will ask you to the drivers, which means the OS knows only the drivers of its CPU. Say it has a driver for a motherboard, it has a driver for your audio, it has a driver for your monitor, it has a driver for keyboard, it has a driver for every device which is already there. Because without drivers it cannot talk. So now a new device has come in. So that it doesn't know. Then it will ask, I need a driver. I don't know this HP printer, I need a driver. So HP printer will tell, I have a driver which can talk to the OS. So that's the reason we download a driver of Windows 7, Windows XP, Windows 10 or iOS driver or a Linux driver. Once it is installed onto your system, now the OS can talk to the printer. Without that it cannot talk. So very similarly, if your mobile is there, there are many things which are there. You have a keyboard, you have a camera, you have Bluetooth, you have a display, USB, many things you have it in your mobile. For every hardware device in your mobile, you need a driver to talk because it's an OS. Without that, you cannot take a photo, you cannot listen to the music, you cannot do the Bluetooth connectivity, you cannot have a Wi-Fi connectivity. For every small device in your mobile requires a driver, or else you cannot talk. So this is nothing but the driver part. Coming on to the above part is the native libraries and the Android runtime. Native libraries are nothing but for your development applications you require say an SQLite database which we spoke. It's a database which is there inside and it can be accessed using a C or C++ functions. Then you have a media which we say that it could be a MPEG-4 or audio or a video media. You have OpenGL, like you want to develop an graphic gaming application. You have a graphics, you have a security system over here. The libraries, you are developing an application, you want to provide some security level kinds of a thing you have. So various libraries, basic libraries which you want to talk to your kernel have been written. This is exclusively written for Android. So these things have been taken from the Linux, but this is exclusively written. This is just a tweak. It has been tweaked for your mobile, but this is exclusively written for Android. So these are the basic libraries written using C++ and exclusively for kernel, because Linux was mainly, it was built using C++ language, not with Java, because Java applications are built only above your Linux, because it is platform independent. Do remember that. Next, the another important part which you have to consider is Android runtime. The core libraries which we say I have to talk here. What do you mean by a DVM or a JVM, or what do you mean by Android runtime? In simple terms, I'll tell you. You will be writing a code, say Java import, and you'll be writing some main function. When you write such kind of a program which is either C or C++ or Java. But now we are exclusively talking about a Java application, which means you are not talking about C++ are not actually platform independent, they are dependent. So a Java program has been written. This Java program is compiled using a Java C compiler. Then it gives you a program which is in the form of a bytecode actually. This bytecode is very big, it is very huge actually. So this bytecode cannot be run on a mobile device. Your Android cannot understand your bytecode. So what do? We have another compiler, we do here as Java C. One more time, this bytecode is converted into a DEX file. Again here also compiler, or we can call it as a compiler. So this bytecode, Java bytecode is converted into the .dex file. Actually when you are opening your application, this is how it looks like. Say your WhatsApp application, you clicked on it. So in which format it is? It is actually in the DEX format. We do not see the extension actually, we see hardly WhatsApp, but you can always remember it is nothing but WhatsApp.dex, because Android can run only the DEX files. Once you have a DEX files, once you click on the DEX file, it tries to execute the application. At that point of time, the DVM comes into picture. At that point of time, the DVM comes into picture. Or Dalvik virtual machine, or we can call it as JVM, Dalvik virtual machine. Then what do we have? Along with the DVM, we can, this is converted into the machine code. So your Java program is converted into the bytecode using a JavaC compiler. Bytecode is converted into DEX file using a compiler, and this DEX file is converted into a machine code using Dalvik virtual machine. So this is nothing but this is completely done at the runtime. That's the reason we call it as Android runtime. This is at the compile time, and this is at the runtime. So your WhatsApp application is in DEX format. You click on it, it converts a DEX file into the machine code using a DVM. So it is happening at the runtime. It's the execution time which we call it as. That's the reason we call it as this is a Android runtime. Simple terms if I have to say. Do remember. It is very similar to our JVM or JVM, or we can call it as CLR in .NET. JVM in our Java, CLR in our .NET. So this is actually how exactly our Java program written, Java application is getting executed here, and then it talks to your kernel, OS. So this is how it works. The next part is application framework. What exactly is application framework? It has got an activity manager, Windows. Yes, now this is Java actually. If you remember, this layer is written using Java. Why do we say it as a Java? Because this above everything, whatever you say is Java, because it is platform independent. So now, why do we need all these things? Because you are developing a mobile application, which we are not developing a desktop or a web application. So if you are developing a web application, you know how to use HTML, how to draw a button, how to draw a text box, how to do a list view, everything. But how do you do all these stuffs in our Android application? You need a screen, you need a button, you need a list view, you want to display items, menu items, you want to bring up a notification, you want to listen to the incoming broadcast things. Many things are happening exclusively in your mobile. So all these are exclusive mobile APIs which are supported using application framework. Say a telephone manager, if you are making a call, so how the looks it should be, how it should be connected, though that is an application for it. You have package manager, which means when you develop an application, how it should be packaged with all additional libraries. That is nothing but content provider. You want to access to different applications and different data available in mobile. WhatsApp want to access your contacts. WhatsApp messages wants to access your contacts. Then that is supported using content provider, because it is mainly deals with your data or a database. Content provider is exclusively for database. Then window manager, how your UI should be managed, how it should be closed or it should be a small button, all these things are taken care. Activity, actually screen which we call it as actual window is nothing but your activity. One after the other, you have to navigate to the front, you have to come back. All these things are managed using your activity manager. So exclusively you are developing as a user or as a developer. If I am developing an application, I'll be accessing the APIs using this framework. So all our built-in functions which we develop is accessed using Java application framework. Next, on top of it, what you have is our system applications as well as user applications. Contacts and alarm, we can call it a system applications, and WhatsApp and camera, this is nothing but a user applications. So the overall application or under architecture, this is how it looks. From the hardware to the applications. This is nothing but a stack. This is nothing but a stack. So with this, so few other stuffs when you're developing an Android development environment, what all other stuffs you require? You require a Java development toolkit, which means because all your applications can be written either using Java or using Kotlin. But initially decade it was developed only using Java, so you require a JDK. You need an IDE, integrated development environment, which is nothing but, IDEs are nothing but our text editor where you can write your code in high level language. You can write it where you can compile. You have many compile, debug, test or AVD. All those things is nothing but integrated development environment, which we can call also as Android Studio. Android Studio. Next we have already spoken, we have to develop an application we require SDK also, which comes with loads of libraries. Then we have Android development tools, ADT, or we have, which is part of your developing AVD, which we Android virtual device, because we supports you, gives you a virtual mobile, which means you don't require to, if you want to after development, you don't need an actual mobile to be tested. You have virtual device, various thousands of virtual devices has been provided. So that is supported using ADT, Android development tool. So to develop an application, we need an environment which consists of JDK, IDE, SDK and ADT, or we can AVD. So with this, so this is how, and this is with respect to the Java or Android application development platform. If you want to develop, you need to know the architecture, you need all these tools, then you can get started with your application development. In the next class, we will be looking into exclusively on the first Hello World application will be executed on your screen, and you can see on a mobile your Hello World application, your first mobile application using Android can be developed. In the next class, we will be developing first Android Hello World application. So what exactly we learned today? So we got to know what is Android, why Android is required. We got to know the Android software stack, which has got from the Linux kernel, the native libraries, Android runtime, Java application framework and application, or which we call it as Android architecture. Then we went into the Android development environment. So with this, I'm going to end today's session. So hope you people have enjoyed and learned from today's the important session of module 2, the Android architecture. Thank you all.